And Martin, if you're in the room, good.
Good afternoon. My name is Tom Daly. I'm with Dynamic Network Services. Today I wanted to introduce to the NANOG community something we created called OpenBFDD. So bidirectional forwarding detection is defined by RFC 5880. It is a protocol that can be used to trigger more timely reconvergence of routing protocols that are running across shared media paths. So you can pin BFD underneath OSPF, BGP, other routing protocols that usually use hello timers to trigger convergence events and allow BFD to establish the fact that the forwarding plane over that shared media path is actually operational and that packets can be forwarded over the path. And if for some reason packets can't be forwarded over the path, rip the routing protocol down much more quickly. So we almost get sonnet-like reconvergence for routing protocols when link alarms are forwarded out to the edge devices in the network with this. So here's just kind of a simple picture of that, right? You have your Ethernet layer down at the bottom. Let's say it's 2 routers on either end and 2 switches in the middle. You have BFD running on top of that circuit with something like a 1 second packet check running through those forwarding planes on those devices. And then on top of that, typical IBGP adjacency with a 180 second keep alive session. So without BFD, if something happens to the underlying link, it's going to take 180 seconds for that BGP session to reconverge. It's got a timeout. Hellos have to expire. With BFD in place, depending upon your routing implementation, it'll actually signal to the overlying routing protocol and say, hey, we don't have forwarding capability anymore. Rip down the session right now, and your network reconverges faster. So at Dyne, we don't actually use BFD for that at all. We use it for something totally different, which is Anycast within the data center, so that way we can do low latency, low cost load balancing. So everybody's seen this before. You do it with ECMP, some sort of IGP to signal next hop availability up to your router, and then the router says, oh, I have multiple paths to the same destination, and if I configure my router appropriately, I get ECMP load balance per packet through that router. Now you get something that kind of looks like load balancing, but is really just layer 4 hashing, and if your distribution of clients coming into your application is diverse enough, you get something that looks like load sharing. So we did this in our network with OSPF and ECMP to start. We were running Quagga on every service box. The service VIP itself was on the loopback of the box. OSPF would take that loopback announcement, inject it into OSPF. The router would say, hey, I have equal cost paths to a lot of different places, and I get some load sharing. As we all know, you can do that on the 2-tuple or the 4-tuple. The nice thing about this is if something goes wrong with your service daemon, just rip down your OSPF session, right? Just make that session go away, and now you're not sending traffic there anymore. But you have a reconvergence that has to happen up on your edge device. So that can take, depending upon your hello timers in your routing protocol, up to 180 seconds to reconverge. And we said, that's not good. So that's what this network diagram, that's what that looks like. You just have unicast interfaces on the ETH0, you have your service addresses bound to VIPs, you have a local LAN, the ETH0 interfaces are passive, and the loopbacks participate in OSPF. So that's what the load balance route looks like in a Juniper, just for reference. So we said, well, this is great, but once you scale OSPF to maybe like 16-way or 64-way ECMP, if a machine should come out of that routing protocol because you either took it down or there was an outage, you're putting a lot of strain on the router CPU to recompute topology during that reconvergence. And we said, there's got to be a better way, and we started thinking about what BFD can do for us. So seeing that there was no viable open source implementation of the BFD protocol, we started writing OpenBFDD. It runs on top of FreeBSD at the moment. It enumerates next hop availability between data center edge routers and internal service machines. So rather than having that OSPF area between those 2 machines in the router now you just have point-to-point BFD sessions between the edge router and the machines that are providing services. And if you configure your router to look at the BFD session, you can see that these BFD sessions are up over to some FreeBSD boxes, and then you have multiple static routes that are being load balanced or load shared, if you will. It's not true load balancing with having multiple next hops enumerated. And that's kind of where we're at. We have an implementation. The actual process that you can run is called BFD Beacon. It'll bring up and negotiate an asynchronous BFD session. We're working on swapping out the event libraries, so that way it'll be supported on multiple operating systems. Right now it's limited to K-Event, which only runs in FreeBSD. And at some point, we don't need it, but somebody else might, and we might implement it anyways, which is full support for demand mode and echo mode in BFD. So check it out. It's up on GitHub, github.com/dynix/openbfdd. That's it. Hope you like it, and hope somebody finds it useful. Thanks.
Any questions for Tom? No. Okay. Next we have